The resistance per centimeter of a meter bridge wire is R with X ohm resistance in the left gap. Balancing length from the left end is at 40 centimeter with 225 ohm resistance in the right gap. Now the wire is replaced by another wire of 2R resistance per centimeter. The new balancing length from the setting will be. But that is a direct question actually. You see, they've given the meter bridge like this. This is a left gap, this is a right gap, and this is a meter bridge. So we know that in the case of meter bridge, there is no role of this resistance per centimeter of the wire or per meter of the wire, because see, they are telling that in left gap they X and in this gap they are connecting 25 ohm, and balancing length is 40 centimeter, and here it will be 60 centimeter. Okay, this is the meter bridge question. Now we can write X into 60 is equal to 25 into 40. Even though you multiply the resistance per unit length of the wire, then it will cancel from the both sides. That means independent of the resistance per centimeter or per meter of the wire. So if the balancing length is 40, even you change the wire, the balancing length will not get affected and it will remain the 40 centimeter. A direct question. Even you are not required to touch the pen while solving this question. Very simple. In the meter bridge, the resistance per centimeter of the wire does not affect the meter bridge or balancing length.